Let's now take a look at example 5, which brings us back to proportions. So we have a categorical variable, although there's no context here. This is just in general. So suppose I'm interested in understanding the population parameter pi, and I hypothesize that the true value of pi is 35%. That means my null hypothesis is that pi equals 0.35, so I'm making that assumption about pi. I collect a sample, and my statistic p hat is 18 out of 40, which is 0.45. Calculate the standard deviation of the normal distribution, and we have to think about why is it okay to use a normal approximation. So that's a theory-based method, and we have at least 10 successes and 10 failures. In fact, we have 18 successes. That's the 18 out of 40. The statistic is the proportion of successes in the sample. And if there were 40 total in the sample, that's our sample size, and 18 of them were successes, that means 22 of them were failures, so we've met that threshold. All right, so we're going to use this little formula. The standard deviation of the null distribution can be approximated by this formula. So we're going to substitute in for pi what we're assuming for its value in the null hypothesis. And you remember that n is the sample size, so that's going to be 40. So you should pause the video and put this into your calculator and make sure that you can get the right answer. When I do it, I get approximately 0.075, and so should you. And now we want to label the grid marks on this distribution that's pictured here. So this is a bell-shaped distribution. It's a normal distribution. Now, how do we know what number goes in the center of the horizontal line there? Well, this is a null distribution, so it's based on assuming the null hypothesis is true. So we're going to put the 0.35. So if I were looking at this in the applet, and I can click on summary stats, the mean is 0.35, and the standard deviation is 0.075. So now each one of those grid marks represents one standard deviation. So if I take my 0.35 and I add 0.075, I would get 0.425, and these are a little squished, so I have to write really small. So again, how do I get that? I take my 0.35 and I add one standard deviation. And then if you take the 0.425 and you add one standard deviation to that, so 0.425 plus 0.075, you get 0.5. And then if you take that 0.5 and you add another standard deviation, so 0.5 plus 0.075, you get 0.575. So again, you should be trying this also in your own calculator to make sure you can get these answers. Then if we work from the other direction, starting from the center to the left, if we're at 0.35 and we subtract 0.075, we should get 0.275. So again, take 0.35 minus one standard deviation, minus minus 0.35, starting over, 0.35 minus 0.075, and you should get 0.275, and then if you take 0.275 and subtract 0.075, you get 0.2, and then if you're at 0.2 and you subtract 0.075, you get 0.125. So to get to each of these grid marks, I either add or subtract one standard deviation from where I was previously. All right, then it says place the statistic, that's the p hat of 0.45, on the picture. Is that an unusual statistic in this case? So the 0.45 is in between the 0.425 and the 0.5, and it's about a third of the way. Okay, so 0.45 is about a third of the way between 0.425 and 0.5. Now, the 0.425 is at one standard deviation above center, and the 0.5 is 2 standard deviations above center, so the 0.45 is in between 1 and 2 standard deviations above center. Now, if I calculate the standardized statistic, my z-score, again, feel free to look at your formula sheet to remind you how to get that. We take our statistic, 0.45, minus the mean of the null distribution, that's the assumed value in the null hypothesis, divided by the standard deviation of the null distribution, which we calculated earlier, you get 1.33. Right? So that's saying the p-hat of 0.45 is 1 1/3 standard deviations above the center. That's 0.35 of the null distribution. So I've gone 1 1/3 grid marks above center, which is where my red 0.45 is placed. It's at starting from center, 1 1/3 grid marks above the center. Right? And the strength of evidence against the null hypothesis, that's weak. Right? When we're within 1.5 standard deviations, we have weak or little to no evidence against the null hypothesis. So 0.45 then is not an unusual value, right? So up above we had this question, is p-hat equal 0.45 an unusual statistic in this case? No, it's not in the tail of the null distribution. Right, it's more towards the center, it's more a typical value.